Bismillahirrahmanirrahim. Assalamu alaikum viewers, welcome to my channel, and in today's video we'll try to understand the concept of our bearings, which is chiefly taught in higher secondary levels fused with trigonometry. So what exactly a bearing is, let us try to understand this thing in a quick glimpse. That it is basically a method of assigning locations of the far distant points or far distant targets. Okay, it is not usually used for those targets which are quite closely which are situated closely from the point of reference. Okay, so for instance, how we are going to calculate the bearing, what is the method? If I just say that I'm having a certain point here and this is the point of observation, means somebody is standing over here, or there's a certain building where the observer is standing, and at this point the person or the observer is observing another location which is quite far distant apart from this point. So this is the point of observation, and for instance I say the point that is getting observed is over here, and I just call it B. Okay, it could be anywhere, it could be here, 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 whatever. So that's it. So this is the point of observation or point of reference, or you can also call it reference frame or whatever. Okay, and this is the point to be observed. Okay, this is the point to be observed. All right, that's it. Now once this is the point where you are observing this one, so at the point of observation you just manage here a north axis. You just draw an axis that you call a north axis. Okay, so you are going to develop here a north axis, and with respect to the north axis you are going to find out the bearing angle. So bearing is actually an angle that helps you to assign the location. So before drawing the north axis, you just have to join these 2 points and get a proper line segment, and after that you are going to develop a north axis at the point of observation. Okay, so first of all let us draw the line segment from here to here, and then we develop north axis. Okay, this is it. So for my convenience, because I have managed all the 4 directions here, though there is no such need, but this necessity comes out when you are managing some problems related to the bearings. So over there you can find the need of drawing all the 4 directions. That's why I just managed here how to draw just to show you how to draw the 4 directions at the point of observation, though presently in the explanation it is not required. Okay, so I'm just trying to find out the bearing of B from A. Okay, so I have just managed north axis here at the point of observation. Now I'm going to calculate the bearing by managing an angle which is so developed clockwise from the north axis, and it is going to stop at this line segment over here. Okay, so this is a clockwise movement. So how you're going to manage this, you're just going to put the protractor over here, and then you start calculating the angle from 0, 10, 20 and so forth till you stop here, and you're going to find out whatever the value is. You just write over here, and remember, whenever you find bearing having acute angle, you always express your bearing angle in 3 digits. So if you're having an acute bearing, you are going to write 1 0 extra in the beginning, and then you just write down the angle. So for instance, I just say that once when I measure this angle from here to here, I just find out that it is 45, just for instance. So I'm going to write the bearing angle 045 degrees. That's how it is written. So this is what you call the bearing of B from A. You can notice here that The point of observation is written after from, and the point to be observed is written before from. So you can also take a key from here, that whatever the point is written after from, you're going to develop north axis at that point, like that. Okay, and then you're going to calculate a clockwise angle from the starting from the north axis and ending at the line segment, which is so obtained by joining these 2 points. All right, so now in the same way, if we just try to find out what could be the bearing of A from B, now at that time we are going to develop the north axis at this point B, because at this time now you are standing over here and you are observing this point. Okay, now the condition is reversed. So how we are going to do this? So let us try to draw a same figure over here. Okay, so this time we are going to calculate the bearing of A from B. So at this time, this is my point of observation, this is the point to be observed. So I have just drawn the north axis and the south axis at this point B. Okay, the point which is written after from. That's how you can get the idea. So we are going to calculate a clockwise angle starting from the north axis, and it ends at this line segment AB. So it's going to stop over here. So you can observe that this is going to be a reflex angle. Okay, this is going to be a reflex angle starting from here. This is going to be 180, and this value more from here to here. So exactly, this is from this point to this point, this is your 180, that's understood. But what is going to be the value from here to here? That's what we are going to find out. So in the beginning, we have just calculated this thing. We are going to take the help of it. So I just say that this was the north axis over here. Okay, and we just calculate the bearing previously, and it was 0.45 degrees. Okay, so according to the major properties or characteristics of the parallel lines, if you're having 2 parallel lines, they are intersected by a transversal. So whatever the angle over here, if the angle over here, that's what you call the alternate angles. The same story is over here. You're having 2 parallel lines, which are the north and south axes. This is the transversal. This AB is behaving as the transversal here. So whatever the angle over here is the angle over here. So from here to here, this is also 45. Okay, so this is your 180 and this is your 45. So this total angle is going to be 180 plus 45, and it gives out to be what? It gives out to be 325. Yeah, so this is 325 degrees. So the bearing of A from B is 325 degrees. So it is already in 3 digits, no need to write extra 0 here. So that's how we do. Okay, so now let us try to figure out an example involving bearings, and let's see how bearings helps us in determining the location of the far distant objects. It could be vehicles, it could be aeroplanes, jet fighters, it could be submarines, it could be a simple ship, and whatever. Okay, so it is usually used by the navigators and by the marines. That's what I have observed. Okay, so let's move ahead and try to see the example. Now here you go, an example. Let me just move a page a little bit upwards so that I could find enough space to write down. Okay, so this is your beautiful example. Okay, sorry, I'm just trying to adjust my position. Okay, so this is a ship. It says that a ship sails 35 kilometers on a bearing of 42 degrees. How far north has it traveled? How far east has it traveled? That's what we have to find out. So first of all, we are going to construct here a beautiful figure, represent the bearing of this ship equal to 42 degrees. So first of all, we are going to assign here point of observation by our own, and we just say that this is the point where the ship is standing, and now it is going to move, and then it will cover 35 kilometers at the bearing of 42. Okay, so finally where it is going to approach, finally what could be its destination, what could be its target location, that's what we have to find out. Not to find out, that's what we have to draw actually. So let's try to draw the figure. I just say that this is the point where the ship is going to take the start. Okay, the ship standing presently, and I just call it point A. You can call it point O, whatever the variable you want to take, you can take it. Okay, so this is it, and over here, from this point, it's going to move. Okay, so it means you have to maintain a north axis here in order to assign the location, in order to maintain the bearing. Okay, so at this point you are going to draw a beautiful north, south, east and west axes, and then we are going to calculate the bearing of 42 degrees. So allow me to draw here the 4 directions, so give me a break. Okay, so I have just managed here all the 4 directions, though the west and south directions aren't required here. There's no such need here. But you see, just developing half of the compass isn't going to beautify your bearing work. So that's the reason why I just draw all the 4 axes and that's it. So there is nothing to be too much serious by taking these 2 axes, okay? So, alright, so now, before drawing the bearing angle from starting from the north axis, where we are going to stop, okay? So first of all, it's prudent to assign the scale, because we cannot draw 35-kilometer long line here on a piece of paper. So of course we need a scale here. So I just say that if I just take 5 kilometers equals to 1 centimeter, that's quite good. So it means that if I multiply both sides by my 5, I come to know that 7 centimeter will be equal to your 35 kilometers. All right, sorry, it's 35 kilometers. That's it. Okay, so we are going to draw a 7 centimeter long line after managing 42 degrees. So I'm going to put my protractor exactly over here like this. I'm going to start calculating the angle from here, from the north axis, clockwise. So this is, for example, 0, this is your 10, 20, 30. And suppose that your 42 is coming over here. Okay, so you are going to draw a 7 centimeter long line, and somewhere it is going to stop here. This is going to be the target point. Okay, so let us draw a 7 centimeter long line. Okay, so this is said to be the destiny of the ship after covering the 35 kilometers, which is actually your 7 centimeter long line, and it covers bearing at the bearing of 042 degrees. All right, so this is the point, a target point. Okay, then it says that how far north has it traveled. So in order to find out the distance in a north direction, how much it has traveled after coming this point, so what you are going to do, this is your target point. So at the destiny, from the destiny, you are going to follow a projection on the north axis. Okay, so if we just draw a perpendicular line falling from B on the north axis, wherever it is going to stop on the north axis, that is going to be the distance so covered on the north. Okay, so let us just try to draw a projection line here. So that's how you go. So over here it touches the axis, north axis over here. You can name it, and I just say it is C. Okay, so you have to find the distance from A to C. That's what it means, at how far north it has traveled. Okay, because you see, the one method is to move 35 kilometers at the bearing of 42, and you can achieve at this, you can reach this point. And another method is to move this much distance on the north axis and this much distance on the east axis, and then you reach at this point. So there are 2 ways. So this is the shortest route comparing this. So what to do now? This is your beautiful right triangle ACB, and you know the angle is 42 here. So with respect to 42, this is going to be the adjacent side, this is going to be the opposite side. This adjacent, this is the opposite, like that. So you have to find out AC here in part A. So which trigonometric ratio will help you here? You can take the help of your SOHCAHTOA over here. Okay, for those, it is for those who find hard to remember the formulas. So you're going to take the help of your SOHCAHTOA. It is sine equals to opposite upon hypotenuse, cosine is equals to adjacent upon hypotenuse, and tangent is equals to opposite upon, it's a opposite upon adjacent side. So that's what it means. So it is simply an acronym of all this stuff called SOHCAHTOA. Okay, so over here you can see the adjacent side. You have to find out. Hypotenuse is given to you. The angle is over here. So cosine is going to help you out. So in part A, the cos of your 42 is equal to adjacent, which is AC, explaining how far north, and this is your hypotenuse, which is 35. All right, so once when you just multiply your 35 with your cos 42, you're going to get some answer. So let us try to calculate through calculator. Let's see what it gets. Okay, so this is your 26.01 kilometers. So how far north it has traveled? It has traveled 26.01 kilometers. That's what it means. Okay, so now the next part is that how far east has it traveled? That's what you have to calculate. So for this purpose, what you do, you just follow projection from the destiny or from the target point. You are going to follow projection on the east axis. Okay, it is going to fall somewhere here. So you have to calculate the distance from this point to this point. That's what. And you can see that this is going to be exactly equal to this distance. Okay, so let us follow projection first. Let's see how it looks like. Okay, so the projection, once when we just make it fall on the east axis, it is touching over here. So we just call it point D for our instance. So we have to calculate distance from A to D. Okay, and you can notice here that this AD distance is exactly equal to BC distance. You can take the help of this triangle once again, and at this time we are going to find out BC, which is just going to explain that how far east has it traveled from here to here. Okay, so over here once again in triangle ACB, we have to find out the opposite side this time. Okay, which is equals to the how far east distance, AD. So as you can see that BC line segment is exactly equals to your AD. That's why we are just taking the advantage of this. And you see that this time opposite is required, hypotenuse is given, the angle is also here at your service. So this time your sine, opposite and hypotenuse, this is going to take the help in getting the distance how far east. So it is sine 42 equals to your opposite, which is your BC. Also you can write AD here, and this is upon 35. Okay, so BC, which is also your AD, equals to AD is equals to 35 times sine of 42. So once when we activate our calculator, we just come to know that our answer is 23.4 kilometers. All right, so if your ship travels 26.01 kilometers and then it covers 23.4 kilometers here, then in that case as well it can reach at the same point. And another shortest route is to move 35 kilometers at the bearing of 42. It can reach at this point. So this is actually 49.51 kilometers total. So definitely this is the longest route and this is the shortest route. Okay, it's like that. You can see this distance plus this distance give you 49.41 kilometers, and this is simply 35. So this is the shortest route. Okay, so that's how we just figure out how far north and how far east distances with respect to the bearings. So I hope the concept is clear. Let's try to move on to one more example. Okay, so again we are having a ship and it sails 200 kilometers, a big distance, on a bearing of this much degrees. It's the reflex angle, and we have to find out how far south it has traveled and how far west has it traveled. So let us construct a figure here, and we just consider that let this be the point of start and we just call it point A. And at this point we are going to develop north, south, east, and west axes. Okay, and then we will try to manage this bearing. Okay, so let us draw the axes. Okay, so here we go. And now, first of all, let us maintain a scale that 200 kilometers is going to be, how much centimeters is going to represent 200 kilometers. So I've decided to take a scale over here such that 1 centimeter will be equal to over 50 kilometers. How about that? So if you multiply both sides by over 4, we come to know that 4 centimeters is going to represent your beautiful 200 kilometers. All right, so this is it. Now we have to find out 243.7 degrees where it is going to situate. Okay, so we have to calculate, the bearing is always calculated clockwise from the north axis. So you're going to put your protractor, where you're going to put the protractor, by the way. You see that this is your 180 degree fully, so some angle you need over here so that it should be equal to your 243.7. So if you just subtract 180 from this, you come to know that how much angle you have to take over here. So it is going to be 63, yeah, it is 63.7. So how you're going to put, you're going to put your protractor over here, okay, and then you start calculating your angle from 0, 20, 30, and 60 might be, 63 might be over here. So the angle 63.7 is somewhere over here, okay, after putting the protractor here. Okay, this is your 180, this is your 63.7. So combinedly, this whole thing over here till here is 243.7. So let us try to draw a 4 centimeter long line in this direction. Okay, so here you go. You can see that the angle from here to here is 243 degrees, and just the angle from here to here is 63.7. Okay, so let me just try to manage. This is your 180, and from here to here, this is going to be your 63.7, so I should use a different color. But the angle from here to here, from just here to here, is 63.7. This is going to be your 180. So combinedly, it is going to represent fully 243.7 degrees. All right, that's how you just try to manage your reflex bearings. Okay, so now you have to find out that how far south it has traveled. So what to do, this is your south axis, this is your target point or the destiny point, so you're going to follow projection exactly over here, same thing that we did in our previous example. So let us try to follow the projection from this point on the south axis. It is going to touch over here maybe, so we have to calculate the distance from the point of observation to this point. Okay, so that explains that how far south it has traveled. Okay, so this is your point. From here to here, you have to calculate the distance. You just call it point C. Okay, and if you just try to rotate this figure a little bit here, like this. Okay, this is your triangle ACB, because the 90-degree vertex always comes in the mid, you know that. This is your 90, and the angle from here to here is 63.7. So with respect to this, and I just forgot to write this thing, it is 200 kilometers. Okay, so you can see that the hypotenuse is given to you, and you have to calculate the adjacent side with respect to 63.7 is the adjacent line. So you have to find out AC, which is the adjacent side. So once again, take the help of your SOHCAHTOA. You come to know that cosine will help you here. Okay, so let me adjust a little bit. Okay, so again, take the help of your SOHCAHTOA. Okay, so you can notice that cos 63.7 degrees is equal to your adjacent side upon hypotenuse. This is your adjacent, this is your opposite with respect to this angle. And so adjacent side is our AC here, upon hypotenuse is 200 kilometers. Okay, now make a nice multiplication and you come to know that how far south the ship has traveled. 63.7 degrees, and this thing shows that it is 88.6, yeah, 88.6 kilometers. Okay, that's how far south it has traveled. And the same way, how far west it has traveled, you just follow projection from your destiny point on the west axis. You come to know that it is going to touch maybe somewhere here. You have to calculate this much distance from A to this point. Okay, and it's exactly equal to your BC, you can notice. Okay, so okay, I just call it point D, and you can see that AD length is exactly equal to your BC length. So this time opposite side of this triangle you have to find out, so nothing but the sine is going to help you. So sine 63.7 degrees is equals to the opposite side upon your hypotenuse. So BC, which is also equal to your AD, is equals to 200 sine 63.7. Okay, so it is equal to 179.3 kilometers. My calculator is too swift. Okay, so that's it. So this is the how far south, this is the how far west. Okay, so once if you cover 179.3 kilometers, and then first you cover 88.6 kilometers here, and then 179.3 kilometers here, then you achieve this point. And this is indeed quite if you sum up these two distances, it is obviously greater than 200. So this is the less route, this is a small route as compared to this. So for example, you're having some kind of danger here, some kind of hurdle or any kind of threat, and you can, in order to find the alternative, you can move from this point to this point and this point to this point to achieve the point B. So that's how you do. So that's how the navigators take the decisions, and that's, I hope you have understood. So okay students, if you find this video helpful, at the end, my most common statement is try to subscribe my channel. I'll be very grateful to you, and don't forget to hit on the bell icon to keep on watching my new videos. You will keep on receiving the updates, and put down your, please just write your feedback in the comment box below, either positive or negative, and so that I could keep on improving my videos quality. And don't forget to like and share if you really liked it. There's no compulsion. Take good care of yourself, inshallah. I'll soon see you with some more helpful videos. Allah Hafiz.